Welcome, explorers, to a journey into the hidden corners of our universe. Have you ever imagined a tiny, silent world drifting in the blazing ocean of the sun? That world is Mercury, the closest planet to the sun. At first glance, Mercury seems nothing more than a cold, lifeless stone, silent and unmoving. But don't turn away so quickly. Beneath that seemingly dull shell are secrets that have left astronomers bewildered. The scorching heat on Mercury could burn away every trace of hope. And yet, at its poles, water exists. Silent streams resisting the desert of fire. The more scientists study Mercury's surface, the more they are stunned. Here, the rarest impact craters in the cosmos quietly exist, alongside landforms never before seen by modern science. Even though Mercury is so small, it wields a magnetosphere strong enough to shield itself from the wrath of supernovae, and a fragile atmosphere that, by all logic, should have vanished long ago. If it were you, would you believe such a tiny, seemingly mute planet could hold so many mysteries? Today, join us as we step into the world of Mercury and unveil the untold secrets of this miniature planet. Have you ever imagined a world just half the size of Earth, yet governed by such strange and unexpected laws of motion? Mercury, with a radius of only 1,516 miles, quietly circles the Sun at a mere 36 million miles away, about 2.5 times closer than our own planet. That's why, here, a year slips by in just 88 days. But beneath the relentless sun, temperatures soar to a scorching 800 degrees Fahrenheit, only to plummet to a bone-chilling negative 290 degrees at night, as if heat and cold are locked in an endless tug-of-war on this tiny sphere. What kind of life could survive such extremes? Stranger still, Mercury spins so slowly on its axis that one Earth day equals 59 Mercury days, meaning a single sunrise and sunset here stretch out for 3 long months on Earth. What causes such a slow, mesmerizing rotation? For ages, people believed the sun's tides chained Mercury in place, locking it in eternal day or night. But that shadow of belief has faded with time. Mercury is not bound by tidal forces as once thought. Instead, it moves in a mysterious dance with the sun, a spin-orbit resonance, turning on its axis 3 times for every 2 orbits around its star. What would it feel like if a single day lasted an entire season? If you were there, would you choose the searing day or the frozen night? These are just the first questions on our journey through the enigma of Mercury. But somewhere in Mercury's distant past, a colossal collision with a giant object likely sent its spin rate spiraling into chaos. The pockmarked scars scattered across its surface, from countless impact craters to the vast, haunting Caloris Basin, still whisper the ghost stories of ancient cosmic violence. Yet, on the other hand, scientists like Benoit Noel and his team have suggested a different tale, that Mercury has been dancing in this spin-orbit resonance almost since the dawn of its creation. So, what is the real story? Was Mercury's fate etched into its core from the very beginning? Or did the random fury of a cosmic collision shape its destiny? Another equally mysterious force shapes Mercury's world, its eccentric orbit. Unlike most planets, Mercury's path is stretched and misshapen, more like an egg than a circle. Because of this, Mercury's distance from the Sun is always shifting, sometimes as close as 29 million miles, other times drifting as far as 43 million miles away. Just imagine a world where every twist and turn on its journey means a new dance of temperature and sunlight, endlessly changing with every orbit. And that's not the end of Mercury's secrets. Only recently have scientists uncovered a new and baffling peculiarity hidden within its path around the Sun. Are you curious to discover what lies ahead? Strangely enough, the abundance of potassium is lower than that of sodium. Yet these two elements drift across Mercury's surface in almost identical patterns. Then, in 1998, scientists made another startling discovery: calcium, its presence nearly 1,000 times less than sodium. But soon, data from the MESSENGER probe in 2009 uncovered a new secret. Calcium gathers mainly near the equator, in sharp contrast to the patterns of sodium and potassium. With every silent orbit, elemental traces whisper tales of meteor showers, each impact searing the planet's face, vaporizing materials, and quietly feeding Mercury's delicate exosphere. Most strikingly, in 2008, a meteor shower linked to Comet Ankh gave MESSENGER the chance to capture rare moments. FIPS detected not just scattered molecules, but also unusual ions drifting near Mercury. Among them, ionized water vapor and ionized hydrogen sulfide, with abundances of about 0.2 and 0.7 relative to sodium. Beyond that, other silent wanderers, hydronium, hydroxy, ionized molecular oxygen, and ionized silicon, are present as well. During its 2009 flyby, the ultraviolet and visible spectrometer UVS on the MASCS instrument aboard MESSENGER unveiled the presence of magnesium in Mercury's exosphere for the first time. Astonishingly, this newly detected magnesium hovers near the same abundance as sodium, as if the elements are performing a mysterious symphony around the planet. Yet, all of this unfolds in a ghostly mist so thin that exospheric densities barely reach 105 particles per cubic centimeter, producing a pressure so tiny it's almost lost in the cosmos. 9 atmospheres, a number adrift in the vastness of space. And more curiously still, the temperature of Mercury's exosphere shifts from element to element, molecule to molecule, as if each carries its own silent rhythm, its own lonely story in the cold of space. Can you believe that fragments of the comet Shoemaker-Levy 9 fell to Earth back in 2013? Pieces of this cosmic wanderer were found scattered across the wide Atlantic Ocean on distant islands like Hawaii, Spain, and the UK. More than 100 kilograms of cometary remnants have been gathered by human hands. And even now, tiny specks continue their silent plunge toward our world. Strangely, amid the vastness of space, Mercury's influence on Earth is often overshadowed by massive neighbors like Venus and the mighty Jupiter. Yet, Mercury's impact on our blue planet runs deeper than most would ever guess. A striking example lies in the unusual perihelion of Mercury, a riddle that puzzled astronomers for centuries. They noticed that Mercury's path was not the perfect ellipse Kepler had envisioned. Instead, the orbit showed a subtle but peculiar kink near the Sun, a mystery that scientists once blamed on an undiscovered planet beyond Neptune. But the truth only came to light when Einstein unveiled his theory of general relativity. It turns out, the planet's odd trajectory is a natural result of the space around the Sun, curving like an invisible river. Today, modern studies are casting new light on Mercury's secrets. Recently, scientists found that Earth's gravity affects Mercury far more than expected, shifting its orbit by about 46 arc-securi with respect to the Sun. This effect is laid bare in the data from the BepiColombo probe, Mercury's silent companion since 2018. At first, some believed that a cloud of dust and gas called the heliosphere might have been responsible. But the probe's sharp-eyed observations hint at something far more mysterious. Now, researchers are daring to suggest the existence of an unknown planet, several times the mass of Earth, quietly circling the Sun. For now, it's just a hypothesis. To unlock the truth, scientists will need more observations and sharper measurements of Mercury's path. Meanwhile, the analysis of Mercury's soil continues, as scientists pore over the chemical makeup in hopes that the probe might return with organic compounds, a discovery that could shake the very foundation of astronomy. What if such an inhospitable world as Mercury once sheltered a whisper of life? Would you ever have imagined that? If you're fascinated by the journey to distant worlds and eager to uncover the universe's greatest mysteries, hit the like button, share your thoughts in the comments below, and spread the spirit of discovery by sharing this video. Don't forget to subscribe so you can join us on every new adventure across the wonders of the cosmos. To truly touch the secrets of Mercury, NASA had to risk everything by landing a probe on its surface. That historic moment unfolded on April 29, 2025. After separating from the main spacecraft, the descent stage plunged toward Mercury at an astonishing speed of 55 kilometers per second, creating a spectacular impact that scattered thousands of fragments across the planet's surface. Perhaps it will be decades before we finally receive images of the site where the probe landed. And who knows, maybe we'll even discover the last remnants of that courageous machine. But Mercury was not the only goal. The BepiColombo probe was entrusted with the task of exploring other planets in the solar system as well. For instance, in July 2021, it captured breathtaking images of Venus during its second flyby on its way toward Mercury. The third and final flyby of Venus took place in 2022, just before the probe slipped into Mercury's orbit for good. And now, let's explore some fascinating facts about this mysterious world. Have you ever wondered after which god Mercury was named? Still, as much as we yearn to unravel Mercury's mysteries, studying this elusive world up close remains an almost impossible challenge. From ground-based telescopes, even at the very best moments, tracking Mercury at night is a daunting task. Because of its tight embrace with the sun, Mercury rises only alongside the brightest star in our sky. And if you dare observe Mercury for too long in the daylight, the fierce sunlight can damage even the most advanced optics. Yet, the obstacles do not end there. This tiny planet is even harder to reach than the most distant corners of our solar system, thanks to the sun's powerful gravitational pull and searing heat. That's why any spacecraft sent to explore Mercury must approach with utmost care, navigating a long and perilous journey, always dancing on the edge of temperature limits just to survive. For all these reasons, only two missions, Mariner 10 and Messenger, have ever braved the voyage to Mercury. Without their daring adventures, we would hardly know the wonders and secrets that Mercury guards so closely to this day. Mariner 10 was the very first mission in history to harness the gravitational pull of another planet, Venus, as a cosmic slingshot on its way to a distant world. The spacecraft sailed through space, using the gentle pressure of solar radiation on its twin solar panels like wings catching the light. Armed with an array of sensitive instruments, Mariner 10 confirmed Mercury's surface was blanketed with craters shining faintly like the moon, while also detecting the planet's ghostly magnetosphere and whisper-thin atmosphere. But the journey did not stop there. Mariner 10 revealed for the first time the existence of Mercury's immense hidden core, and managed to measure the temperature on both its sunlit and shadowed sides. More than 2,700 images were captured and sent home, allowing scientists to assemble a map of nearly half the planet's mysterious surface. Although Mariner 10 never entered orbit around Mercury, and made only 3 daring flybys, each 6 months apart, it still carved its name as a pioneer, sparking a breakthrough in our understanding of this enigmatic world. The mission of Mariner 10 lasted nearly a year. After completing its orbit around the Sun in late March 1975, the spacecraft quietly fell silent, ceasing to transmit any radio signals back to Earth. Perhaps, somewhere out in the dark, Mariner 10 still drifts around the Sun, a ghostly sentinel carrying secrets through the endless night. 30 years later, a new chapter began. the Messenger spacecraft took up the torch. In 2004, Messenger not only flew past Mercury like its predecessor, but also became the very first craft to orbit the planet, unlocking a trove of richer, deeper, and more fascinating data than ever before. Messenger's great ambitions were to collect vital information on Mercury's chemical makeup and its exosphere, to explore its magnetic field and the forces that shape it, and to trace the echoes of geological activity from the past while probing the state of Mercury's core today. Before settling into orbit, Messenger completed 3 patient loops around the planet, gradually slowing its dance as it drew ever closer. From the beginning of its flight, and by 2014, the craft had captured and sent home an astonishing 200,000 images of Mercury, with a total of 2,500 close-up shots, each one a priceless fragment in the unfolding puzzle of the Sun's closest companion. In early 2015, Messenger began to run dangerously low on fuel. By the end of April 2015, the spacecraft finally came to a standstill and plunged into Mercury, carving out a brand new crater in the planet's lonely surface. All in all, the Messenger mission lasted a full decade, 10 years of relentless exploration, filled with countless surprising and fascinating discoveries. Its greatest achievement was nothing less than the very first complete map of Mercury. Every crater, every ancient basin etched onto the planet's surface was captured in detail, giving scientists a gateway into Mercury's geology and the mysterious depths beneath. Beyond that, Messenger unlocked the secret code of Mercury's chemistry. Its surface holds 46% oxygen, 12% magnesium, 26% silicon, 7% aluminum, and 4% calcium. Each number tells a story, a cosmic whisper of the origins and transformations of this sun-drenched world. The spacecraft also revealed a startling truth to scientists. Mercury's surface contains a huge abundance of sulfur, but much less iron. Not only did these numbers surprise, but direct images of gentle, sloping volcanoes suggested that in ages past, Mercury may have been volcanically alive, perhaps even cloaked in a global ocean of molten magma. As the planet gradually cooled after such violent geologic activity, heavy elements like iron sank deep toward the core, explaining why so little remains at the surface. During this magma ocean era, Mercury's atmosphere was choked with volatile substances like sulfur, sodium, and chlorine, all of which would only vaporize under intense heat. Scientists propose that the raging magma melted not just the crust, but even the planet's interior, though not enough to shrink Mercury's mass in any significant way. Now, the fires inside Mercury have gone silent. As the world cooled, it began to contract, forming cracks and ridges all across its face. Alongside traces of ancient lava flows, Messenger also uncovered. If you're fascinated by the journey to distant worlds and eager to uncover the universe's greatest mysteries, hit the like button, share your thoughts in the comments below, and spread the spirit of discovery by sharing this video. Don't forget to subscribe so you can join us on every new adventure across the wonders of the cosmos. Alongside traces of ancient lava, Messenger also uncovered water deposits at Mercury's poles. Even though the planet's surface burns with searing heat, water persists here in the form of ice, forever frozen because the poles are shielded from the sun's direct rays. These silent glaciers, untouched for millions of years, pose a tantalizing question. Could there be liquid water hidden deep within Mercury, beneath layers of ash and dust? While that mystery remains unconfirmed, the mere possibility awakens new hopes about what secrets Mercury might still conceal. Messenger also astonished scientists with a surprising discovery about the planet's magnetic field. It turns out that Mercury's magnetic axis is shifted, displaced by as much as 20% of the planet's radius. Such a strange anomaly could have dramatic effects on the planet's surface. For example, solar wind particles would bombard the southern regions with greater intensity, eroding elements from the crust. And finally, in 2011, Messenger captured a breathtaking photograph from Mercury's orbit, showing nearly the entire solar system, all except for the distant, dim Uranus and Neptune. The last time such a portrait had been taken was by Voyager 1 in 1990. And now, Messenger had carried on humanity's legacy, recording the story of our cosmic neighborhood in precious images. Still, the most captivating revelation brought back by both spacecraft was Mercury's enigmatic surface. Let's take a closer look. Here, the topography unfolds like a vibrant tapestry, painted with endless contrasts. Although nearly the entire surface is pocked with countless craters, there are also expanses that are almost perfectly smooth, as well as ridges and deep troughs winding across the landscape. It's nearly impossible to pinpoint the exact number of craters, but so far, scientists have named about 567 of them, each one a tribute to a prominent figure in history. Most of these are impact craters, scars left by violent collisions with small cosmic bodies. Experts divide them into simple and complex categories, depending on geological features such as sharp peaks, terraces, and concentric rings sculpted into Mercury's crust. Simple craters dominate, especially in the southern hemisphere, and typically measure from 0.6 to 9 miles across, with depths of less than 7 miles. Complex craters are less common but far larger, ranging from 10 to 168 miles in length and plunging deeper than 7 miles. Each hollow is an epic story in stone, bearing witness to the stormy, tumultuous history of this little world. However, Mercury boasts more of these topographic scars than any other body in the solar system. Scattered across its battered surface are 110 craters with central peaks, while, for example, the Moon has only 17 such features. Alongside the average small impact craters, Mercury is also home to giant structures called impact basins, which can stretch to a colossal 200 miles wide, or even reach an immense 963 miles. These staggering numbers can be explained by the ever-increasing velocity of bodies in solar orbit and the planet's almost non-existent atmosphere. Some of the most celebrated basins are Caloris and Rembrandt. Caloris is Mercury's crown jewel, the largest crater, measuring an astonishing 963 miles in diameter. In panoramic images, scientists have found its floor was once flooded by lava, leaving behind smooth, shimmering plains at its base. It's believed that the cosmic body that slammed into Mercury to create Caloris may also have given rise to the planet's chaotic terrain, a land sculpted with furrows and oddly shaped plains. Rembrandt, the second largest basin, is about half the size of Caloris, but evidence suggests it too was once engulfed by lava, which explains the remarkably smooth terrain around it. Beyond these titanic basins, Mercury shelters other intriguing craters. For instance, the Thick Basin is thought to be the oldest on Mercury, possibly over 4 billion years old. It also lays claim to the darkest place on the planet, covered in fine particles ejected by ancient volcanoes. And there are still more rare mysteries waiting to be uncovered. Mercury is also home to some truly unique types of craters, including elliptical, polygonal, and ghost craters. Each has a different story, a unique mechanism written by the wild hands of the cosmos. For instance, elliptical craters are born when a slow-moving but massive space body strikes Mercury's crust. These make up about 2 to 4% of the surface. The largest elliptical crater, Sven's Daughter, stretches an impressive 137 miles long, carving a mysterious scar across the landscape. Polygonal craters, those with multiple sharp angles, likely arise due to the battered, fractured nature of Mercury's ancient crust, causing impacts to create jagged outlines instead of smooth rings. There are about 33 such polygonal craters on Mercury. Ghost craters, on the other hand, are barely visible, their bottoms long ago filled by flows of lava. Yet, what sets them apart are the ridges circling their edges, left behind by the rapid buildup of molten rock. Each of these strange forms is a silent witness to Mercury's restless history, to the drama etched in stone beneath the blazing sun. And still, there remain other rare and mysterious types of craters waiting to be revealed. Another type of crater, which can also be clearly seen on the Moon, is the ray crater. Its most striking feature being the long, raised lines that diverge from the center and stretch immense distances. On Mercury, these spectacular lines reach their longest at the Hokusai crater, where the rays extend for a staggering 2,800 miles. Bright scars etched across the ancient surface. These marks appear when a powerful impact throws subsurface material outwards, and as the ejected debris fades with time, the brighter the ray, the younger the crater. Thanks to these craters, scientists can study the dynamic history of Mercury's geology and, among other things, estimate the planet's age. Young craters tend to be convex, with terraced walls rippling down their sides, while older craters are much shallower, likely filled with volcanic material over eons. Interestingly, while analyzing the types and sizes of craters, NASA researcher Caleb Fassett noticed that Mercury seems to lack craters ranging from 12 to 80 miles across. He suggested this could be due to the frequent formation of inner crater planes early in the planet's history. High surface features like ridges and escarpments are not overly abundant on Mercury. There are only about 100, and each upland formation was shaped in a different era, molded by the planet's own fierce transformations. The process that creates these hollows has not ceased, meaning Mercury's surface may continue to transform with every passing age. Scientists estimate that in 1880, just 25 million years, 99% of Mercury's face could be completely reshaped. Mercury is a priceless laboratory for studying the dynamics of surface change and the mysterious mechanisms that create alien landforms. That's why, in 2018, a new probe was launched to carry on the legacy of its predecessors, BepiColombo. This mission is made up of 2 separate spacecraft, set to observe Mercury both from afar and up close at the same time, pushing the frontier of discovery even further. The primary mission of BepiColombo is to answer the questions Messenger left behind, to dig deeper into the origins and causes of the magnetic field's strange displacement, to uncover the truth behind the water deposits at the poles, to solve the riddles of Mercury's cavities and how they are born. If all goes as planned, BepiColombo should enter Mercury's orbit in 2025 and begin its boldest work yet. With hope, these new explorations will finally unravel many of the secrets of this mysterious planet and offer us profound insights into the story of the entire solar system. If you're fascinated by the journey to distant worlds and eager to uncover the universe's greatest mysteries, hit the like button, share your thoughts in the comments below, and spread the spirit of discovery by sharing this video. Don't forget to subscribe so you can join us on every new adventure across the wonders of the cosmos.